Good morning, class. Today we're going to discuss Chapter 11, Physical and Chemical Control of Microbes. We're going to distinguish among the terms sterilization, disinfection, antisepsis, and decontamination. About 50% of my class last semester got this wrong on the quiz, wrong on the exam, and wrong on the final. How could you do that? Can I sterilize my skin?
No.
Can I sterilize this table? It's an inanimate object. I am an animal, an animate object. We can only do sterilization on an inanimate object. Can I disinfect my skin? Let's do this chapter here. We're going to identify the types of microorganisms that are most resistant and least resistant to control measures. Compare the action of antimicrobicidal, C-I-D-A-L, that suffix "cide," C-I-D-E, means to do what? To kill. There's a difference in killing microbes and inhibiting their growth. We're going to compare the action of microbicidal. What's the key with cidal? It's a killer. And microbistatic agents. Static, another suffix I want you to just be able to tell me what that is. We'll get to it in a minute. And provide examples of each. We're going to name 4 categories of cellular targets for physical and chemical agents. Historical methods of microbial control have included salting food, smoking food, pickling food, drying food, exposing food, clothing, and bedding to sunlight, burning clothing and corpses, storing water in copper and silver containers. Sterilization is the destruction of all microbial life. So when a surgical tech hands the doctor an instrument in surgery, is that instrument what? Sterilized. Disinfection destroys what? Most microbial life, reducing contamination on what kind of surfaces? Inanimate. So back to the question, can I disinfect my skin? Antisepsis, it is also called degermation, the same as disinfection, but it's on a living surface. So what are some antiseptics I can use for antisepsis? Come on, what can I do? I just failed and scraped myself. What, huh? I should that way they will do with a eye problem, huh? Hand sanitizer, what's that? Hand sanitizer has some what in it? Alcohol, so that would help me a little bit. How about some others? Soap and water, they're good for you, but they are not going to kill bacteria. They're not going to. Peroxide, okay. How about iodine? Anybody ever heard of iodine? I guess it's not real prevalent now. Like methylate mercuric form. You hadn't heard of those before. Y'all are too young. What year were you born?
99.
2000, 99. Ooh, Lord. 99. My son was graduating from high school. 2000, I was thinking about retiring. I retired once. I'm going to retire again. I retired when I was 54 and had worked 33 years at Bell South AT&T. That was pretty good, wasn't it? Yeah. 33 years on many, many jobs. And now I'm going to retire from this one someday. All right. Oh, I didn't mean to put that on the recorder. Decontamination is also called sanitization. It's the mechanical removal of most microbes from an animate or inanimate surface. Can I decontaminate this stapler? Can I decontaminate my skin? Okay, it's the only one, isn't it, that says animate or. All right, if we look at these different methods, physical agents, chemical agents, and mechanical removal methods, under physical agents, we have heat and radiation. We have two types of heat, dry heat and moist heat. Today in lab, when you incinerate your inoculating loops, what will you be doing to them? Sterilizing them. Incineration produces sterilization. In a dry oven, you get sterilization. What about with moist heat? Steam under pressure. Sterilization. What if I just boil some water? Like people think that when they boil their baby's glass bottles, that they are sterilizing them. But what does boiling water, hot water, and pasteurization produce? Disinfection. Then under radiation, we have ionizing and non-ionizing radiation. Disinfection is produced with ultraviolet light. Where do we get that? Sun. Can you go sit out there on the back porch? I just imagine I'm at the beach somewhere and lay back and soak the sun in. Ionizing, which includes X-ray, cathode, and gamma ray, produces sterilization. Now, what was the woman's name who discovered the structure of DNA? But she died before she could get the Nobel Prize for it. What was her name? And what did she die of?
She died from the radiation.
She died from the radiation. She had an X-ray almost every day. And what was her name? Biology 103? Nope. Anybody remember good old Rosalind? Rosalind, what was her last name? Okay, all right. Now, under chemical agents, we have gases and liquids. For sterilization, we have sterilization and disinfection that occur with gases. Liquids, we have liquids that we use on animate objects and liquids that we use on inanimate objects. The ones on animate objects, we are doing antisepsis, which what is the definition of antisepsis? Degermation. What are you doing? You're getting the germs off. It's the same as disinfection, but it's on a living surface. So is it destroying all microbial life? It's not the same as sterilization, is it now? Look there. Most? Okay. That's the difference. Then we have mechanical removal methods of filtration. Filtration of air and filtration of liquids. Sterilization. Questions? The primary targets of microbial control, microorganisms are capable of causing infection or spoilage. What's a microorganism capable of causing infection or spoilage? How about go with spoilage? What happens to your bread? Okay, causing infection. What happens when I have some staph on my skin and it breaks the skin and goes on the inside of my body because I scratched it? Rash, I will have a staph infection. when I scratched the skin and it went on the inside, I should have just come in the house after I was outside moving over leaves and things that had not been moved since 2 seasons ago. I should have gone in the house and taken a what? Shower, quick. Because when you start scratching yourself, and scratch it so hard because it's itching so that you break the skin, you don't know what you're letting on the inside. Staphylococcus aureus. The microorganisms are constantly present in the external environment and on the human body. Often contains mixtures of microbes. Here is the relative resistance of different microbial types to microbial control agents. From the bottom to the top, they are less resistant. To the top, more resistant. We have prions, bacterial endospores. Bacterial endospores, keep that in mind, that endospores are more resistant than, say, Mycobacterium, Staphylococcus, protozoan cysts, trophozoites, gram-negative bacteria, fungal spores, non-envelope viruses, and most gram-positive bacteria. Bacterial endospores are considered to be the most resistant microbial entities. Destruction of endospores is the goal of sterilization. Any process that will kill endospores will invariably kill less resistant microbial forms. Does that make sense? If it'll kill an endospore, it'll kill anything. It'll kill it on any. Other methods of control are disinfection, antisepsis. And the big difference between disinfection and antisepsis is what? Tell me right now. Disinfection does what? I want you to tell me what it does and on what kind of object. All right. Disinfection. Antisepsis. Okay. All right. Here's a comparative resistance of bacterial endospores and vegetative cells to control agents. What's required? How much heat is required to destroy endospores? 120 degrees Celsius. How about vegetative forms? Only 80. Endospores are what? More resistant than vegetative cells by 1.5 times. How about radiation? Any form that is not the endospore that has sprung off from it. How can I say that? The endospores are a dormant, sometimes, form of the bacteria that comes from the bacteria, and it keeps it where it can have any kind of harsh conditions, but it's still alive on the inside there. If it's a salt thing, it can go to fresh water, or if it's hot, it can go to cold. Radiation X-ray dosage. So the live form of a bacteria it requires less heat, radiation, sterilizing gas, and liquids to destroy its cells. So which one is harder to destroy? Endospores. Keep that idea. Truth, when you looked at your watch, it made me look at mine. Sterilization is a process that destroys or removes all viable microorganisms, including viruses. Any material that has been subjected to this process is said to be sterile. Sterilized products are essential to human well-being, such as surgical instruments. You want them to be sterile, don't you? Syringes, commercially packaged foods. Disinfection, the use of physical process or a chemical agent disinfectant to destroy vegetative pathogens, but not bacterial endospores. Disinfectants are normally used only on inanimate objects. Does anybody have a question about why I've said that 4 times already? Antisepsis. Sepsis is the growth of microorganisms in blood and other tissues. Asepsis is any practice that prevents the entry of infectious agents into sterile tissues and prevents infection. Aseptic techniques. Ding ding, bell going off. Aseptic technique. You know all about that, don't you? You're going to know more today. Sterile methods that exclude all microbes. Antisepsis is the application of chemical agents, antiseptics, to expose body surfaces, wounds, and surgical incisions to destroy or inhibit vegetative pathogens. Cidal, C-I-D-A-L agents. What did we say the word cide means? C-I-D-E, the suffix, to kill. A germicide or a microbicide are chemical agents that kill, K-I-L-L, microorganisms. A bactericide is a chemical agent that destroys bacteria except for those in the endospore stage. Fungicide kills fungal spores, hyphae, and yeast. A viricide inactivates viruses, especially on living tissue. So did it say it killed the virus? Because the virus is not a cell, right? The virus has got to be on a whole cell in order to carry out its life function, right? So, viricide, it inactivates the viruses because they are not living. But those viruses are on or in living tissue. A sporicide is capable of killing endospores. That's heavy duty. Static. Microbes are prevented from multiplying but are not killed. What does the suffix static mean? Static. Static means that the microbes are prevented from multiplying. So that means what? They don't grow anymore. There's no growth. But are not killed. Again, everybody wake up and zoom in on this right now. Microbes are prevented from multiplying. They don't grow, but are not killed. So what's the difference in cide or cidal and static? Merci beaucoup. Donc, bacteriostatic agents prevent the growth of bacteria on tissues or objects in the environment. A fungostatic chemical inhibits fungal growth. A microbistatic agent includes chemicals that are used to control microorganisms in the body, antiseptics and drugs. Decontamination, another word for decontamination is sanitization. This says sanitation. In some documents you'll see it's sanitization, but it means the same thing. Any cleansing technique that mechanically removes microbes and debris, reduces contamination to safe levels, and a sanitizer is a soap or detergent used to sanitize. So earlier, Miss Ma'am, when you said soap and water, that sanitizes. It doesn't act as what were we talking about? Antisepsis? Antiseptic. All right. Decontamination, antisepsis, or degermation, reduction of the number of microbes on the skin. We're all talking about the skin. Involves scrubbing the skin or immersing it in chemicals or both. You'll have a lab called hand scrubbing that you'll get the opportunity to scrub your hands. It emulsifies oils on the outer cutaneous layer mechanically removes potential pathogens on the outer layers of the skin. Some practical concerns in microbial control. Does the item in question require sterilization, or is it disinfection adequate? It depends on the item. What items do you want to definitely be sterilized? Name some. Anything that goes in your body. Definitely the surgeon's instruments. How about processed food? You don't want to learn that your Spam or some of those other processed meats that my husband likes to make sandwiches with. You want to know that it is sterile, produced in a sterile environment. Is the item to be reused or permanently discarded? If it will be reused, can the item withstand heat, pressure, radiation, or chemicals? Is the control method suitable for a given application? Will the agent penetrate to the necessary extent? Is the method cost and labor efficient, and is it safe? Critical medical devices are expected to come into contact with sterile tissues. Semi-critical medical devices come into contact with mucosal membranes. Non-critical medical devices are those that do not touch the patient or are only expected to touch intact skin. What is microbial death? It's harder to detect than in macroscopic organisms. There is no conspicuous vital signs. Lethal agents do not alter the overt appearance of microbial cells. Loss of movement cannot be used to indicate death, because do all microbes move? You saw some microbes that appeared on your microscope that didn't look like they were moving. You drew them, you identified them, but there were others that were moving. Some of them, anybody have anything that was moving real fast? Like a little bug running all over the place? Didn't have that? Okay, we had a few. Special qualifications are needed to define and delineate microbial death. So factors that affect the death rate: the number of microorganisms, the nature of the microbes in the population, the type of microbial growth, temperature and pH, concentration of the agent, mode of action of the agent, and the presence of solvents, interfering organic matter, and inhibitors. Factors that influence the rate at which microbes are killed by antimicrobial agents. Here we have the number of viable cells at a high number 10 to the 9th, and after a time of, say, 12 to 13 minutes, we had reached microbial death. All right. Same thing here, cells and the time for sterilization. All right, I think I'm going to stop here for part 1 of chapter 11. We'll pick up with slide 22 the next time.